All right. Hello, welcome everyone to another weekly session when we learn how to program Bitcoin smart contracts using Scrypt. So today I'm very excited to present this new feature we just introduced actually yesterday. So because this is very important for any kind of a application that's trying to leverage Bitcoin smart contract. Because as we know, we have shown almost everything regarding about how to the whole workflow about smart contract. We want to say how to create it, how to test it, how to debug it, then how to deploy it. Once you deploy, how to interact with it. But all programmatically. But the problem is most users, they're not going to write some code to interact with smart contract. We need some more user-friendly way, right? So usually when we talk about that is to add some kind of like a front-end UI. So the users can, log into your website and then using a wallet to interact with the smart contract, which I think if not all the apps going to do this, it's just a majority of apps. It's that you're not going to have, users using command line or writing some code to interact with the smart contract. So that's why we need, a way how to integrate the smart contract with the front end. Okay, so that's the motivation. Hopefully that's obvious. So here today, we are just going to introduce, how do you integrate, Scrypt smart contract with a very popular, I think it's probably the most popular front end framework called React. So if you have not heard about React, strongly go to the official website to get a sense, and then come back. So because this is the session when we want to talk about how the integration works, so I'm not going to cover in details how different front-end frameworks such as React work. I mean, if you're not familiar, go to the website, learn the basics at least. So in the next few minutes, I'm going to assume you already get familiar, at least you know the basic of React, okay? So, and also a note here, we use React as just as an example. There are many different front-end frameworks. You have Angular, you have Vue, you have, it's every single month or so you have new frameworks. But in theory, we can support arbitrary front end because this is just for us. It's just a TypeScript library, so we can support any. But so far, we choose to, support only the most popular one. And in the future, we are going to add more and more. So let's get that out of the way. So just in case of the audience today, who's, if not familiar, just at least knows about React? Anyone?
Yeah, I think everybody knows about React, and I am a little bit familiar with it.
Okay, cool, nice. So assume you already, at least know the basics. Let's get it started. So in React, that's almost like a standard way you create a boilerplate project using so-called create React app. Also in short, CRI in short. So you can run this CRI tool to create a sample project. So we are going to call it, hello world. And then because this is the TypeScript, Scrypt library, so we are going to also say, hey, don't use the vanilla JavaScript. You also use the TypeScript template. Okay. So after this, you are going to see a project similar to the one showing up here. Okay. And now we have a React project. Okay. So the next we are going to do is how do we turn the React project, to be Scrypt compatible? Okay. So it's also very easy. We always use the CRI to our CRI tool, Scrypt CRI. So you can just go to the directory, which we just created, hello world, you go into it, and then you run this CRI init. And this, what will this do? it will add all the related dependencies. For example, script.ts and all the development environment set up. For example, you set up all the debugging, launch.json config, you have all the TypeScript config, everything ready. Okay. So once you have run this command, now you have turned the basic React project into an script project as well. So this is finished the setup. Any questions so far? Okay, that's good. So basically you run these two commands pretty much, and then you have a script compatible React project ready to go. Okay. Now let's look at how to integrate. So actually there are two big steps. One is so-called load the contract. Okay. So if you still remember, when we deploy and call or test the contract, we talk about so far before today's session, we always talk about in Node.js environment, right? Because there you can do all the compile, you can deploy, all these things, they run in Node.js environment. So you can think about almost like a backend. But here today we are switching to front end. So most of the case, all the script.js functions work in both the front end, meaning the browser, and also the backend, meaning Node.js environment, except a few things. For example, the compile. You cannot compile in the front end. Okay. So the workflow is at the backend, you compile and then deploy it. Okay. Once you compile, you get some kind of like an intermediate like artifact, which we call for example, after you create the hello world smart contract, okay, so if you run compile, you get a JSON file. This JSON file, now this one can be loaded in the front end. So from then on, at the front end, you don't need to compile, okay? Because first, you cannot compile at the front end, and also second, that's what it will take a lot of resources to compile. So that's why another reason we don't do it at the front end. So instead, you kind of decouple the back end and front end by at the back end, you run this command to generate this almost like a compiler output file called, hello world.json. Okay. So once you have this JSON file, you can load it at the front end by using this. Again, this is the same thing. This is the same. You can import the smart contract using this import. And then how do you load the JSON file? You get the load into the JSON file, and then you call this load artifact on your smart contract. So after this, at the front end, this hello world is the same as what we had before. After you call hello world.compile at the backend. Now it's just like any other smart contract class we have seen before. So you can initiate it by calling its constructor, and then from then on is behave exactly like any smart contract instance at the backend we have seen before. So any question so far? I think this is the only difference when you want to work with the smart contract class in a browser environment versus the Node environment. Clear?
Yeah, I think so.
Okay, cool. Yeah, that's seems easier than I thought. Okay, so in summary, basically, you compile, you get a JSON file, and then in the front end, you load the artifact JSON file, and then from then on, it behaves exactly like the smart contract class we have seen before. Okay, so that's the first big step. So you have to load the contract artifact at the browser, and then the next question is, so previously we talked about different signers, right? Each signer you can also think about the wallet. So we talk about, we have a test wallet, which is mostly, as the name suggests, used for testing. But I also have a MetaMask-like wallet called SenseLeak. So we want to integrate with browser-based wallet. Okay. So again, this is not very different from before. So you create a provider and then you create a signer. Okay. So then somehow you need a way to say, hey, from my front end, I want to access the wallet. Right? So basically it's almost like a login. You want to log in using the wallet. Okay. So what do you do? It's also very simple. For every signer, it's a full wallet, full suite wallet. You can just call request authentication. Okay. So if signer requests the auth, if everything works out, you should have a pop-up saying, hey, the user has to click to confirm to log in using the wallet credentials. And then from then on, this wallet, it has been, hooked with your app. So whenever you need to sign transaction and broadcasting, there's always a pop-up, and then you can confirm, and then it's going to authorize to perform the actions the users requested from then on. Okay. So here, once you request authentication, if it's good, then you're good. Now these two are hooked. Otherwise, it will throw an error, right? So for example, here, once the app now has been bounded with a wallet, you can say, hey, what's the default address for the wallet? So you can, for example, after you authenticate, you can perform all kinds of, actions. Okay. So once you have, bundle with a wallet, login using a wallet, then the rest is the same with before, right? So once you have the instance, you create here. So you can, again, say the same thing, say dot connect, okay? And then from then on, this is exactly like what you had before. So you can call a method as usual. For example, we showed how to, once you have an instance and connect to a signer, which is a wallet, so you can use in the same context, same syntax we have seen before to call any contract method. Okay, that's basically all the steps you need to interact with a contract in the front end. Okay. Any questions so far?
No.
It's quite straightforward, it seems.
Yeah, seems so.
Okay, very nice. Yeah, that went much smoother than I expected. Okay.
Maybe
nice.
only one question. So, is it possible to create some type of way for the front end to call the back end and the back end to compile and to generate the JSON? So you don't need to do it manually, or because I don't know anything at all about React, but just wondering if this is possible.
Yeah, definitely possible. Yeah. So here's the thing, right? Because we are like at the almost like a developer tool side, so we don't dictate how people do this. We just showing the minimum requirements. How do you integrate? So for that, yeah, of course you can build an app. Let's say some kind of like so for people who have not heard about this, it's like Remix. You almost like a Remix you talk about, Ethereum. So this is like an online IDE. So you can also deploy and compile in a browser. So definitely you can do that. The thing is you can have a React front end or whatever front end you use, and then after you click, let's say compile, it's going to send it to a server, right? And then server perform the compile and get the JSON, send it back to the front end, which the front end can load. I think that's definitely doable. But here again, we only provide the bare minimum. So however you want to deploy, it's all up to you. But the tool is here. For example, here you don't want to, let's say, you don't want to run this command and deploy, and then you want to do this automatically based on the source file provided by the front end, you can also do this by just call this compile at your backend, right? And then the backend, you can send it back. Okay, yeah, that's also doable.
Cool, great, thanks.
Good question, yeah. Anything else?
No, I think we're good.
Okay, nice. I think that's just one way to deploy it, right? We recommend it at the backend, you compile and you can deploy it. And then at the front end, you can just load it, the JSON. This is almost like you can almost think of the result that coming out of the compile. Okay, so you don't have to do it at the at the front end. And also here, we talk about the Sensely, right? This is just one wallet. If you want to add your own wallet, we also have another guide. I think we probably talked a little bit before. You can also add your own wallet support. That's no problem. Same thing for the React framework. You know, this is just an example. If you really want it, you can also hook up, you know, by extend this command, script init. Basically, this init now only works under React, but you can also, you know, we have CI, which is open source. So if you really want, you can also submit a PR. We can add your favorite framework, Vue, you know, Angular, whatever it is, Svelte, whatever it is. Okay, so this is pretty much a platform and a wallet independent. But just so far, we only integrate this specific combination of Sensely plus React. Okay.
Yeah, makes sense.
Yeah, nice. So we only talk about, you know, the bare minimum here. How do you integrate with the front end? But if you really want to see how it works in a practical example, you can always click the link here. So basically, we have this website, which is a very cool interactive learning website called Tic-Tac-Toe. Basically, you can build your contract, which is the first lesson. And then once you have the contract ready, here we can also walk through the different steps, how to integrate with the front end, which we just covered. Here, basic idea, and this is how the idea works in a practical example. So I strongly recommend, if you really want to understand after you finish this, you also go to see how it works, you know, live action, using this practical example. Pretty much you can say, hey, you have an integrated wallet, and then you can also integrate front end. Pretty much it just applies what we just showed to a practical tic-tac-toe example. So, and it's working. So you can also play with, after you finish, you can actually play with it. So this is a full suite example. So here, this documentation you can think of. You can think about this as a complete full stack working example. Okay, so for example here, integrate front end, you know, as pretty much what we just talked about. You know, this is the using CRA to create a scaffolding example, and then call init to turn it into a script compatible example. And also you can compile pretty much just what we just talked about, but just putting a concrete tic-tac-toe example. The same here, you can connect to a wallet. So this has all the sample code, and also when you finish, you also get a small test. So you make sure you actually not only understand the concept, but also you know how to actually do a little bit of code here. Okay. So I strongly, for anybody who's watching, you know, either live or later on recordings. So once you finish this, I strongly recommend to click the link at the bottom and then follow the tutorials to build a tic-tac-toe here. Okay. All right, that seems faster than I expect. Any closing thoughts? And because I would imagine, you know, whatever you learn at all the previous chapters, eventually you are going to edit, you know, with the UI. So users, because otherwise users have no way to interact with the smart contract. I mean, it's cool. You can learn and try using code and CLI, but eventually, if you really want to develop a full suite app, smart contract powered app, you have to use this, this step, follow this step to integrate with some kind of UI. Otherwise, the users cannot. It's impossible for them to use your contracts. Make sense?
Yeah.
Indeed, yeah.
Okay. Any comments? Final?
Final one maybe. So last week we saw the interaction with Watson Chen and how you could verify that the contract was genuine, right? We could see the code. It was, I can't remember. Yeah, it was verified. So is there a way at the moment? I guess it will be manual, but is there kind of a way that to show in the front end that actually the contract you are using is verified, or I mean, as an end user, how can the end user know that the transactions that are produced are using this contract and the contract is verified?
Oh, you always yeah. If you're like an app developer, you develop some app, and you are claiming you are interacting with some kind of a contract. You can always produce. You always have to publish two things, right? It's just one thing. One is the transaction ID, okay, and then you have to go through this process to make sure people at the last they can click, right? They can always click and see if it's verified, because they can always. So if the app developer they verify so anybody can come here and check this has been verified.
Yeah, so
So
there is
basically,
actually nothing you need to do. It's just by having the transaction ID and the link to Watson Chain, provided that the contract was verified. The end user will see the details of the transaction, and in particular will see that the contract is verified. Is that what you mean?
Yes. So then you don't have to trust, the app developer, right? So if it's something very, let's say, you really need to put your Bitcoins into it, and then you really want to have a very high confidence. The contract, for example, even in the front end, right? So front end is also, if you really want to increase the user's confidence, you also have to expose the transaction ID that the front end is interacting with. So in the front end, if you have the transaction ID, and then users can always go to, let's say, Watson Chain and make sure, oh, this is the contract we are interacting with. There's no cheating here. Yeah, that will be a super safe way. But in reality, I think it's a mix, right? So if you're like a developer, you can always go there, and it's always a different level of trust. If you're a developer, you can do this, but if you're just some average Joe, your grandma, provided she's not a computer programmer, she's probably going to just trust the app developer. But of course, that's also highlights one of the benefits, or you can say features of the so-called Web3 apps, right? You don't have to trust it's like a Web2, right? If the Twitter is saying, hey, I'm using this algorithm to rank your feeds, I mean, you kind of trust, right? The Twitter, the company, okay, you are ranking this based on, the time it, chronically, or, based on the follower count. You don't know, right? It's pretty much like a opaque black box. Versus here, if you really want to have some third party you can actually independently audit if you really want. Yeah, I think that's also depends on what the use case. It could be a bigger improvement. So the workflow is you develop your app. So in your app, you hard code, the deployed transaction ID, right, for your smart contract. And then anybody who wants to check whether it's true that you are interacting with this contract, and also you as a developer, the app developer, you also have to go through this process, verify it, and then everybody, if they really want, they can go to What's on Chain or some other block explorer to check this is actually the contract we are interacting with. There's no funny business going behind the doors, and there's no security backdoor. Let's say you can be verified. Yeah, which is I think it's impossible in so-called Web2 or the current web apps. Yeah, so this is also give another idea to see what kind of apps, that's good to have a smart contract behind it, because if you want to have fully transparent and third-party verifiable, for example, right, you want to play some kind of like a, let's say lottery, or you can have some kind of voting. Everybody wants to check. Yeah, this is good use case. That's the contract can be helpful. Okay. All right, cool. Any other question?
No, thanks. All clear.
Okay, sounds good. All right, and just some logistics. There's no session for next week, and I hope to see you all in the next week. Okay, have a good one, guys. Bye bye.
Every time.
Bye bye.